Okay, so today we are going to talk about the intermediate value theorem, and in order to do that, we're going to use my buddy Zaz here, hey Zaz, to illustrate the intermediate value theorem. So here's what the intermediate value theorem says. It says if f is a continuous, is a function that is continuous on the closed interval from a to b, and k is any number between f of a and f of b, then there is at least one number c in a and b such that f of c equals k. Okay, kind of a lot, but let's talk about what that means. So the first thing it talks about is the closed interval from a to b. We're going to say that closed interval represents time. The interval from a to b is time. So Zaz right here, he's at the starting point that he's standing. He is at time a, right? We'll just call it the time a, and he's going to cross the road. And after a certain amount of time, he'll cross that road, and that will be time b once he's gotten across. F of a and f of b are the distances. So he is currently at a distance of f of a meters. So if we want to be more specific, maybe he's at 0 meters. When he crosses, after he's crossed the road, so over here on the other side of the road, we can say he is at f of b meters. So maybe he's 15 meters. Then what the intermediate value theorem says is between f of a and f of b, there is a k, a distance that's in between those two. So we're going to call the road k. And I think you guys agree, just visually speaking, that is between the south side of the road and the north side of the road. So what we want to do is we want to use the intermediate value theorem to show that within a certain period of time, Zaz crosses the road. So let's do that. So here he is starting in f of a. And we're gonna, if I had a stopwatch, I'd hit the stopwatch and I'd say, okay, go Zaz. Let's have you cross the road. So starting at time 0. So he starts at time 0 at f of a. He crosses the road 5 seconds later, and he's at f of b. How do we know that sometime during that 5-second interval, that he had to be at k? Well, here's how we do it. So with the intermediate value theorem, we're going to have to establish two things. One, that k is between f of a and f of b. And I think you guys would agree that the road is between f of a, where he is now, and f of b, where he is now. So we've established that the k value, the road, is in between the two. And we can also establish that he crossed it within the elapsed time that was given. So a and b, right? So he did it within the time period that we were analyzing. So we've established that k is between f of a and f of b. The next thing we have to do is establish that the function was continuous, that he didn't teleport from one side of the road to the other. And since we saw him walk, we know it was continuous. We know that walking is a continuous function. So there is no teleporting, right? So because those two requirements have been met, k is between f of a and f of b, and that the function was continuous, then we can say, listen, by the intermediate value theorem, there has to be a time in which there has to be a time in which Zaz here crossed the road, and it had to be between time 0, where he was at distance of f of a, and time b, where he was at distance of f of b. So now we're going to switch over now, and we're going to kind of prove this using a graph and stuff like that, because it's kind of obviously we need a little bit of stuff to write with. So in the next video, what we're going to do is we're going to establish okay, probably shouldn't have done this on a PvP server. Okay, whatever. I can edit that out. Anyway, so In the next video, we're going to actually use a graph and we're going to establish exactly how the intermediate value theorem should look for this situation.